You feel totally scary robot voice. Even if you feel totally, especially if you feel totally safe in this class.
Can't hear anything.
Can you not hear me?
What the fudge is going on?
We can hear you.
Okay. I think that might just be on Amy, unfortunately. So, psychological safety survey, please fill it out. It's short, it's simple, it allows us to give feedback to the TFs, tell them what they're doing well, tell them how we could be making the classroom better and a better learning environment for you. Each classroom's different, so the only way I know how to adjust is by your comments and feedback. So I appreciate you filling it out. It is an assignment on Canvas, but I will post a little reminder in the Slack, as always. The other thing, some of you have met Taylor, our wonderful success coach. Taylor is available for basically anything that's life related. If you have something that's interfering with your ability to successfully be in class, Taylor's your person. Taylor has some great techniques for mindfulness, great time management skills. Frankly, I need those time management skills. So you are always welcome to contact her, and I have made it even easier to contact her. I have put on the main page of Canvas, so if you just go to learn.launchcode.org, there is now a success coach request form. It is 1 question, or 3 questions, sorry. It is what your name is, what, if anything, you want to disclose before the meeting, and how you can best be contacted. And so that is just another another way to reduce the barrier to contacting Taylor. So please feel free to do this. Finally, today an assignment was due. It was not a drop assignment. It is not the big scary assignment 1 drop assignment. But if you did not turn it in, I will be contacting you so we can kind of make a plan to keep you up. The scary thing is, the hard, honest truth is, these assignment dates are set for a reason. Maybe you didn't get the assignment in immediately prior to class. That's okay. Turn it in after class. But the further you get behind, you know that this class moves fast, and you know that once you get behind, it's really hard to catch up. So if you didn't get the assignment in by tonight, we'll probably have a conversation. It's not scary. It's not punitive. It's just, how can I help you get caught up and stay caught up? And of course, you can always reach out to me prior to that conversation if you are having trouble, and let us make a plan for you. That's all I have. Hopefully not too scary. Couple to-do items for you, and a request that you can always contact me if you're having trouble in class. And now I will pass it over to, am I passing it straight over to Bree?
Yep, go for it. And then Bree, I will make you co-host here. Perfect. Thanks, Clark. There you go, my co-host. Perfect. Bree, you should be able to unmute yourself now.
Okay, hopefully y'all can all hear me. If you don't know who I am, I'm one of the TFs. Just a quick introduction. I work as a support agent for a company called Octane, which is owned by Stamps.com, doing things with SQL databases and the software that we use to allow people to do shipping from multiple platforms. Just a brief overview. Today, I will be talking about unit testing. My teaching style is a little different than Kyle's. It's a little more interactive and a little more let's get some experience on it, especially for unit testing. I feel that unit testing is, it's a very important part, and it's really about the logic. So a lot of it is the logic, and it's what we're going to try to learn today. And as I code live, be more concerned about understanding the logic than about copying what I'm coding, because we can go back and you can look at the video, and one of the repos that I'm using has solutions that I will provide as well. So we'll be able to look at that, and it's pretty detailed. So it's just a matter of trying to follow what I'm doing, but not necessarily type everything I type. So if you run into errors, we won't stop to approach individual errors, but you can ask your TAs, your TFs later, or you can try to copy what I have, and I will share the final code at the end as well. I did post those 2 Replit links and announcements, so I would go ahead and copy those because we will get to those fairly quickly along in class because that will be the majority of it. I'm going to go ahead and start sharing. Can we have captions turned on? Yes, yes we can.
Captions should be turned on.
Okay, are they on? I see them now, wonderful. Okay, let me share screen. I will be able to watch lecture questions too, so I can see those if there will be points that I ask for input. Lecture questions is the place to go ahead and answer that. I will not be watching lecture chat. So lecture questions, if I ask a question and I want what should we put here, that's where you want to provide it. And we will begin. Okay, so this is unit testing. The slides are going to be a little short, and then we're going to dive into actually working on some stuff. So what is unit testing? Unit testing is being able to automatically test things. So like when we were using our programs in Hello World and Scrabble Solver, and the first one that we did with the console.log and the test, a lot of the times you would console.log out your data to make sure that you had the right thing. You would be like, is this working? You would click run, type in your questions, and make sure that it would work right. You were testing your program. Well, unit testing let us automatically test it. Instead of having to manually go, it will test for us. It's commonly done with test frameworks. There are lots of test frameworks. These are 5 common ones. In unit, Mocha and Emma are pretty common. Those are C#, Mocha's JavaScript, and Emma is Java. We will not be using those in this class at all. The ones we will be using is Jasmine, which is JavaScript. We'll use it tonight. You'll also use it for assignment 3. And then JUnit will be used in the second unit, and that's a Java-based testing. So those are like 2 of the more common frameworks that are used. If you wish to know other frameworks, there's a long list of them. I'm sure many of the TFs can list them. Almost every TF or TA, if they're a dev or if they worked in QA, they use some kind of test framework. Testing is a huge part of dev work. A lot of the times in real world development, you can't even submit your code unless it has a test written. So tests are a great way of determining if something is going to break. And so this leads us into reasons why we unit test, and it's to check your code deeply. What that means is when we check a code manually, we could sometimes miss certain cases. And we'll go into what those kind of cases are, but you may not always hit everything that will happen. Another thing that happens is sometimes when you add a feature, you break previous features. That is called regression. So we don't want to do that. So we want to prevent that. And so by having tests that work, so we have tests, we have a feature, then we add a new feature. Those previous tests will start to fail if we broke the previous feature. So that way it tells us that something broke without us having to go back and manually test everything. And then another reason that we unit test is called self-documentation, and that's to define what the code should actually do. A lot of the times, if you wind up with code or C code and there's no documentation, but there's unit tests, you can go through your unit test and see it's going to describe how it literally uses a function called describe that tells us what it does and what it should be doing and how it works. So those are the 3 main reasons we unit test. And how we do unit testing comes back to our test cases. Generally, people are going to remember positive cases and negative cases. Those are easy things to hit when you're manually testing. Edge cases, not always easy to manually hit. Okay, so now this is an example. This is what we're going to code with a little. This is going to be a function. It was in your book. It didn't really dive deep into it. but we're going to have a function called set temperature that accepts a number between 50 and 100. And we're going to talk about positive, negative, and edge cases here. We're going to go in depth and kind of answer some of these questions that you have and really try to make this make sense. Now, another thing that unit testing is for is to help maintain your workflow. One of the best ways of workflow is using test-driven development, and that is you write tests, you write code. You write tests, you write code. That's basically your workflow. You make sure that your tests make sense, then you write your code and you see if your test worked or if it fails. Okay, I know I'm moving a little fast. At this point, do we have questions? Is everyone good? Everyone solid? Not overwhelming yet? I do talk fast, so feel free to slow me down. Yeah, Jason, I want to say the answer is yes, but to be honest, I'm not a big fan of the autograder, so I haven't really used it that much like I should have, but I want to say yes, it is unit testing. Clark is nodding his head, so yes. As of right now, we should have the temp test replit. Yep, that is the first one we're going to use. We're going to start with that one, keep it nice and simple. So now we're going to go into, yep, this is our last slide before we go into testing. Test-driven development, TDD. It's a software development process, and it's where tests come first, basically. And this is the logic behind tests. So your test cases are where it helps you develop your code. You should always determine your test cases before you create your feature. They should take in mind what the function should do and require. Something that is commonly known in test-driven development is red, green, refactor. So red is the test fails. Green is the test pass. Refactor is red is the test fail. Green is the test works and the function works. Refactor is improving upon your code and making sure you maintain green. But if you hit red, you make it green again. So refactoring code is your changing of the code without editing the actual feature. So like, for example, if we have a feature that prints my name, asks a bunch of information, prints my name in like a file on me, we could have a bunch of strings, or we've learned objects now. So if we wrote code that just stored it as tons of variables, my name, my age, my height, my weight, all of that, my pronouns, stored all of that, each in their own variable, and we would print all that out. Refactoring it would be going in and using an object instead. We're taking code we already had and improving it by using a new data system. So now we're going to pull up the replit. Where's my mouse? There it is. Okay, I am going to be using VS Code, but it is the exact same thing that you have in Replit. There is absolutely no difference. VS Code is what we will use in the future in this class. So this is just so you can see what it looks like. For the most part, there is zero functional difference. Yes, I can. How's that? Okay, so just so we're all on point, and now would be a good time to either be taking notes or have your Replit open. So you're going to notice it's the exact same. We have set temperature, we have index, and we have a spec file. All of that should already be there. So let's talk about what index.js does. Index.js, luckily for y'all, we haven't actually been coding in index.js for most of your assignments because we've been using a unit testing style for the auto grader. So this is the code that Jasmine requires. First, you have to require Jasmine, then you have to create the Jasmine testing unit, and then you have your, we won't go into a lot of details, but it's just how you load your details, and then it executes. That's all that file does. This file will not be touched, changed, modified. So we'll get out of it. Then we have our function, right? So right now we're going to start with our name of our function. Generally in unit testing, you don't. You usually start with like nothing sometimes, and they tell you from there, and then you create the name. But we wanted to start simple. So our function is going to be called set temperature. It's going to take one parameter called temp value. What our function should do is it should only accept a number between 50 and 100. Under 50, it's going to return low temp. Over 100, it should return high temp. Between 50 and 100 should return temp set. So it's just going to be a function that we call. We give it a number, and it's going to return one of 3 strings. Pretty simple so far, right? Now, you're probably already thinking how we're going to code this, which is how we previously taught. Except today, we're not going to think about how we're going to code it. We're going to think about how are we going to test it. So we're going to move into the spec folder and move to set temperature.spec.js. So here, there's a few things happening. Does the code currently in index.js ever change depending on the project? Yes, but y'all should not be changing it or modifying it, and it should not be changing within this unit at all. Anytime we use Jasmine, it will be that. But as things are bigger and projects are bigger, your Jasmine and your testing unit isn't actually built into index.js because your tests get built into your code that runs at the same time. So you would have your giant project, and then within that project, you have another testing folder. So you would be able to run tests within the project that also runs the project, if that makes sense. So we need a few things first. Is one, we have to make sure that this file, set temperature.js, is inside this file because we have to be able to access it. Now, assert. Assert is a core function of JavaScript. It is not a part of Jasmine. We are not going to use the Jasmine testing. We are using Jasmine to test. We are not using its functions to test. So assert is JavaScript based, which it's part of Node. So I'm going to pull this up real quick, and I will post this link. So this is basically just documentation on assert. Just real quick, these are all the different types of asserts you can have: a deep equal, does not match. All of these are things to just keep in mind in the future and aren't super important today, but they will be important perfectly. I'm sure there might be a typo, but there also might not be a typo. Because let's see. There is actually not a typo if you're saying how I spelled temperature. Because let's see, nope, you're right. I did miss an R. So we'll go over what that actually means, because this typo won't actually break anything. Because this is not calling a function. So as we get there, I'll explain what this actually refers to. Better? Okay, so the first part, the describe, is a function that exists, right? It creates a group of specs, which is generally a test suite. So in this case, all of our tests are going to go within this describe, right? So what goes first is you have your describe, your parentheses. Then you have a description or a string. As you can see right there, it goes description string. For us, what we want to do is we want to describe what it is being tested. So for us, it's going to be set temperature. So what's going to wind up printing is it's going to go set temperature, and then it would print this string on the it, and we'll test it shortly. Right now, it's going to print as that it succeeded because there is no test. Right? So we have set temperature, and then a function. And this is where all of our tests happen. This is a test case right here. This is a test suite. So test cases start with it, right? And then you have your expectation, which is your string. And then you have your function that tests and determine what your test is happening. Those are the two main parts of that. So the first part, on our first test, we're going to talk about what our function is supposed to do. It should only accept a number between 50 and 100. So first, let's test to make sure. Let's do a test called a negative test, a negative case. And a negative case is going to be something that causes it to not work. So our first negative case is give me a number that would be a negative or a failure for this function that should not work. Anyone can give me a number. 45. Yep, we can go with 45. So we're going to go, for here, we're going to go it. So set temperature should return low temp when past 45, right? So this is a literal description of what is happening here. Set temperature should return low temp when past 45, right? So what that means is now, after we've done that, we would now create our test. In this case, it's a pretty simple test. All we have to do is call the function, or we need to go assert here, dot, give me 1 second. Assert dot, we're going to go strict equal, and then we're going to have actual, comma, expected. So now these actual and expected are two variables we have not created yet. And what we need to do is we need to determine what we want. So our expected now our expected should be here. What should our expected be? Yes, low temp. So we're going to go low temp. Now our actual is when we run the function. Let actual equal, and in order to determine the actual, all we're going to do here is call the function. And then we'll plug in 45. That is our first test, right? So now let's go ahead and run this test. So for all of y'all just click run. I do this. So we'll see we get some words this time. Okay, now before I just explain, if you're referring, B. Jones, to when I had temperature spelled incorrectly, that will, you can go ahead and add the R, but it also will not break your code if you leave that not happening, because that is not calling the function. As we can see when we move to failures, that's what pops right there. So any questions before I get into this explanation of this failed test? Feel free to unmute. Let me find that button. No, that's a really good point to notice, because it should be typed correctly, but it actually does not break the code because it's just being used as a description. Where's this button? There we go. Okay. So any questions before I move on?
Yes. If the temperature is past 45, then why would it be lower?
So what this refers to is when past 45, that refers to the terms of passing an argument into the function. So we're giving 45 as our argument. And so this function, when we pass anything under 50, it's supposed to return low temp. That's what we've been instructed to do. So anything under 50 returns low temp. Anything over 100 returns high temp. Anything between 50 and 100 returns temp set. So another way instead of the word pass is when using 45.
Wait till my closest friends.
Does that make sense? Does that help?
No. Could you repeat that?
Yes. So passing an argument is how we call a function. So when you're using the function, you say when past 45, that means we put 45 inside that function. So we went set temperature 45. So past 45 isn't PAST, it's PASSD, as in we used 45 to set the temperature. And this function uses anything under 50 to be determined low temperature. So what's happening here with our failures, and this was supposed to fail, is it said expected values to be strictly equal. We got an undefined, we were supposed to get low temp, right? And that totally works correct. Now, the reason we got an undefined is because we haven't actually created any code. So now we've done the first step. We made our test. Now the next step is we have to come in here and actually make it work. So now we would use an if statement. And what are we looking for here?
Aside from this,
Temp value.
God goes.
If
Temp
set
value.
temperature or
Yep, if temp value
is greater
Less
than
less
greater
than
than the 50,
So Myron, that would be close, but on here, we're actually starting with our negative case. So what we're starting with is we're only looking to make this one test pass. We don't want to worry about if it's greater than 50, if it's greater than 100. We're only worried about if it's less than 50. When you do test-driven development, you specifically focus on the individual test. So the first part is temp value less than 50. And then we go return
hence low temp.
low temp. That is correct. Now we save and we can go ahead and hit run again. Now nothing shows up. What this means is it says one spec zero failure. So we have passed our test.
Okay.
It has now succeeded. So now we're going to do another test. And we're going to go it. So on this test, we're going to go when it's over 100. So give me a number over 100.
101.
5,000.
102.
I would be under, but 101 is good. So then we have to call an extra function. And now right here, we go let expected, which is our expected value we're going to get, and that's high temp. Then we go let actual. And we call our function again. And we pass 101. And we'll go assert. And we see how this is almost the exact same as the previous test, right? That is our second test case. We now have a test suite of 2 cases. Test case 1, test case 2. So let's go ahead and run the code again. and we'll see that failure 1, set temperature, should return high temp when passed to 101. So this one failed. Now, when we go in, we see the green plus is actual. That tells us what it gave. Expected told us what it got, right? This is very similar to what you see in your auto grader. We want to be getting the minus, but we're currently getting the plus. So now we're going to move into
Main program.
better. Is that a little better? Sorry, I have a very big monitor. It's like 38 inches, so my text is usually pretty small. So hopefully this works better for y'all. So now, what is our next if?
Greater than 100.
Yep. And what we're actually going to do here, we're going to do
Or
else if
else.
value. Yep. And we'll return high temp. Now we'll run the code again. And we see that both of them passed. At this point, we have successfully done test-driven development. We have taken a function, we have created 2 test cases, which made a test suite, and created it. So there are still just a few more. We did a negative case, which is the first one, which is when it gives you what you don't want, and then a positive case, which is high temp. Or this is also a negative case, my apologies. A positive case is going to be the next one, which is when it works. So it should return temp set Give me a number that is a positive test case.
75.
I didn't hear that number.
75.
75. So then you have to call your function. This function is always necessary. So you always have your describe, your set temperature, your describe, your description, your literal description of the function that you're testing. Then you have to call function again because it has to run. Then you have your it, and that is saying set temperature, describe it. That is what that means. So then we're going to come down here. There's not a lot of questions so far, so I'm hoping I'm not losing people. So we go let expected, right? And then how do we call let actual? What's going to go here?
Set temperature of 75.
Perfect. We go assert dot strict equal actual comma expected. So then anytime you make a test, you always want to run before you run your code because you want to make sure the test actually fails. It looks like I messed up somewhere. So let's see. I am missing a parentheses. So that's another reason why you want to make sure to run your code to make sure that that is. No, sorry about that. You should use semicolons. I am very, very bad about not using semicolons. That's just a personal preference of how I code. But generally, if you're just learning nowadays, you should use them. It's a bad habit that I have to not use them. So it is just something that I personally do, which is a bad habit. So I would not do that. I would not recommend that you code without semicolons. You should go ahead and put semicolons right there like this.
You have an auto semicolon?
Say that again?
I said, did you have like an auto semicolon?
No, so to not get into it too deep, JavaScript can run without semicolons, but it is not recommended to do so.
Okay.
And when you're a new coder, you can sometimes mess things up, not seeing things well. So semicolons help keep your code cleaner. Once you have more experience, you can generally find your bugs without needing semicolons, which is why we recommend you use them, because they make it easier to read. And I just have a bad habit of not using them. They make it harder for me to read, actually. So now we're going to run this code. And we see we got another failure. Set temperature should return temp set when past 75. Right? So now let's go in here and go to set temperature. Now we need to make it, what's the easiest way to make this work? What's the next part? Go ahead, Tim.
Else, just use an else statement or else if.
Yeah, we'll use an else. And we will return temp set. Now we'll run our code. And it passed. Now, if you remember, I mentioned that there are 3 types of test cases: positive, negative, and edge test case. So what does someone think an edge test case is?
Passing in 50.
Say that again. Passing at 50. That is correct. 50 or 100. Both of those would be edge cases. So now let's write a test for what should happen if we pass it 50 or 100, right? Right now, what we said is it said under 50 should return low temp, over 100 should return high temp, between 50 and 100 should return temp set. Those were our instructions. So we were not given what should happen necessarily when it's 50 or 100, right? But we were told it should only accept numbers 50 or 100. So you always use strict equal to test. You should use strict equal. There are other tests, as in the assert, but generally you want to be strict. You do not want to be loose, because you want, just the same reason we use 3 equal signs and not 2 equal signs. We want the code to do exactly what we tell it to do. So when you use possibly only 2, or you don't use just equals, or any of the other methods there that aren't a strict, then you risk the chance of it passing when it shouldn't pass. Now what we're going to do here is we're going to change our comment a little, and we're going to go 50 and below. Below, and then we'll go 100 and above. So now we're going to come in here, and we're going to go return low temp if past 50. Once again, we go let expected equals low temp, let actual equals set temperature 50. Yep, I missed those. Thank you.
Yeah.
And then we'll go assert dot strict equal actual comma expected. So now we'll go ahead and run this test. We see that it failed like we expected. However, we actually got a temp set returned instead of undefined. So what that means currently is the way our code is currently written is it's sending to temp set. So we have to change our code here to include that. Ignore that that looks different. That is just a text that I use that changes that. That is just a greater, a less than equal sign. It's just going to look a little different than y'all's. We'll do the same. So we should theoretically do that. There would be your next step. That's what you would think, right? You're like, oh, we got to do temp value for low temp, so let's go ahead and edit high temp. That's actually incorrect when you're doing test-driven development because we don't have a test for it. So we should not be editing our code because we haven't written a test for that case. We should only be modifying what we have tests for. Following so far? Any questions at all? I want to make sure I don't lose y'all because this is very important. So I'll pause for a couple minutes. Anyone have questions? Anyone confused?
Bree, I have a question. Right after it, the should return when past 75, is that a string or is that an actual command or function in JavaScript?
This
Yes.
is a string, right? So the way it works is you go it and then parentheses and you give it a string, right? That is when something fails, right? So let's go ahead and we're gonna put 51 here because we're gonna force this test to fail. Okay. So what happens is you see that should return low temp, it prints right there for you. It tells you what that test was supposed to do. Set temperature should return low temp when past 45.
I have a question.
Yes.
Okay, so I've always, ever since the second part of the first unit last time, I have found Visual Studio to be a lot easier for me. And I was wondering, I've never been able to figure out how to do the TDD on Visual Studio because I couldn't figure out how to get something to run. And I just find Visual Studio easier. What extension do I use?
So I would recommend that you reach out after class for that one because there's a couple setup steps that we have not talked about yet in class and we have not gone over yet. So we just haven't gotten there to be able to set this up on your own. But if you reach out to me or maybe even Kyle, we can kind of walk you through it if that's easier for you.
Yeah, because
it's not something we can go through tonight, unfortunately.
Okay, because I did last semester. I was part of the January.
Perfect. Yeah, reach out after class and we can help. Is the strict equal the same as expect to equal, or is there a situation where one is preferred over the other? They are basically the same thing. WEMA. I'm not sure how to pronounce your name, but I'm trying here. Oyoma. The reason I'm using assert is that is what we use in assignment 3. WEMA, I probably killed it at this point. In assignment 3, assert is what is used. So that's why I wanted to go ahead and use assert. Why did the book have us work with expect commands when you are teaching us the built-in assert commands? I don't work in the ed team, Mark, so I have no idea why that is. But I do know assert is what is used or was used in assignment 3 unless they changed it. If Clark's here,
I'm sorry. Sorry to pop in. But they did change it. It has to do, honestly, sorry, I'm gonna have the worst answer. It has to do with the auto grader. And of course I get a phone call right the one time I pop in. You guys are gonna hate that answer, is that it has to do with the auto grader. But it does.
Apparently I'm teaching you the wrong command, but it works the same.
It works identically. It's just a linguistical difference. It's a great chance to read the documentation, but it essentially just has to do with the auto grader being able to basically unit test your unit tests, which is exactly as complicated as you might expect.
Well, I was trying to give y'all a heads up to make assignment 3 easier, but apparently that is not what I did, but that's okay. It does work the exact same way. There's also, Jasmine has their own tools as well. To be honest, when I went through the class, yes, it is literally a case of swapping the assert.strict equal to expect.to equal. That's basically the only difference. Nice and simple. So let's see, we have our test case for 50. Now we have one more edge case. And what's our last edge case?
100.
The reason we use the variables expected and actual is for visual understanding. So documentation purposes. So that way someone can come in and go, it should return load temp, expected load temp, actual set temp. So that way it's this format that is easy to read by any coder. Anyone can look at this and immediately know what it says. So yes, I could just stick load temp and set temperature right here, but this creates a nice, easy flowing chart. And sometimes unit tests get more complicated. Sometimes there's 6 commands, like all of these will be commands. And there's just lines and lines of commands that you have to do before you can actually get to your expected and your actual. So just having it determined what you're supposed to get and then what the actual command is that finally returns your command or returns your value is easier to read and easier to follow. Do we create a test case if a string is inputted instead of a number? Sure, we can make one of those. But let's go ahead and do return high temp if past 100 because it's a test, it's an edge case. These are just basically all the same thing so far. So real quick, due to times, the second repo that I listed, I am not going to get to. However, it does have solutions attached to it, and it is great practice, and everything is very well described and notated within that one. So that is a great one that you can work on your own without having to do it as a group. So we have the failure again, temp set high temp. So we just come over here and we change our 1, right? So we have about 10 minutes left. I can make the test case and we can do that for string or number. Or we can ask other questions as well. This is the main gist of test-driven development. This is how it works. This is what it is. You write your code, you write your tests first, then your code second.
I have a question.
Yes.
Whenever we run the program, we need to pass the parameter in that function. You pass the temperature of 100. I don't want to pass the temperature 100 in the means how we get it.
So you should only be passing, when you're doing test suites and you're testing, you should never be trying to run the code outside of this test. So you should only be going set temperature here, unlike actual, because you're not actually running code like you would be with previous programs. You're letting Jasmine run the code for you, which is a little different. So at no point should we be calling any functions outside of an it statement. Where do I need curly braces? Maybe not. Okay, never mind. Let's see, questions. Assume string true false would be similar. Yep. So anytime if we were going like here, we could also make a test to say if past a string, return failure, or please pass a number. That would be something we could easily do. That would be a negative case. It would not be an edge case. However, a lot of the times you wouldn't need to do something like that because in here it says should only accept a number. So a lot of the times you can expect that when you're writing code like this, it's not going to be given something different. But testing it is still okay as you're getting practice. Can actual and expected to be equal to another function? Can you? I'm a little confused what you mean here. Are you asking if actual can be equal to a function and temp value and then expected can be equal to a function? Yes. Expected and actual can be set to whatever you want. So if you had a situation where you were supposed to, where two functions were supposed to return the same thing when passed the same value, that would be a good time that you would go expected this value. You know that function works. Now your new function, which should return the same value when it's past that, would be your actual. And that would be the two times when two different functions could be included in the same test. But that's a little more difficult than where we're going with this. You should not be needing to do that within this class. Let's see if I missed anything real quick. For the most part, these were the requirements given. So generally when you're creating unit tests, you're given X number of requirements. We were giving 3 requirements: low temp, high temp, temp set. And we met all of those requirements using 2 negative cases, 1 positive case, and 2 edge cases. So we have successfully completed a test-driven development program. So we're just on questions. I don't want to start on anything more complicated, so that way we can get into Studio, so y'all can really play and deep dive. So questions, or y'all are free to go?
Could you just scroll up to the top for
I
me?
have some questions.
Yeah.
Thanks. Thank you.
Can you compare arrays?
I have a question.
1 second, I'll get to you next. When we go, can we compare arrays? You have to remember how we compare objects. So it's a little different to be able to compare objects. I would give you the answer off the top of my head. However, I don't use Jasmine, and I don't want to give you an answer for this that won't work for Jasmine. So give me 1 second.
Unit testing.
So I know I can give you the right answer. Unless another TF knows it off the top of their head, because I do not know the correct format to test objects and arrays in Jasmine.
I'm sorry, Bree, were you talking about testing that as in what assert to use when you're testing it, or a certain regard of how to test something?
Oh, crud, my battery.
I will get back to y'all after Studio today for that question. Amy, what was your question?
When can I go to someone about the stuff with using VS Code
Tonight
instead?
after Studio. You'll have to get with us after Studio. So
okay, thank you.
Yep, no problem. Okay, I'm done. I hope y'all enjoyed. I hope you learned a lot. I hope I didn't confuse you any.
Thank you.
Does the order matter, Ryan? Not necessarily, but it's gonna look weird because it would wind up saying when you failed that your expected was your actual and your actual was your expected, but it will still work. You can stop recording, Kyle.
Yep, perfect. Thanks.